Just see. Okay, so today we're focusing on study unit 9. So last week we looked at confidence intervals, and this week we're taking it a bit further. So moving on from confidence intervals to hypothesis testing. So basically we're still going to use some of the same information that we used nearly going back to study unit 7. So for hypothesis testing, again, we look at the Z values. We'll go back to our tables. We look at how we compare that, what we've calculated to the tables, and then basically we're going to decide if we're going to accept or not accept or the null hypothesis. So that is basically what we're going to do in my hypothesis testing study unit. So as normal, I've given you some information as summary, and what I nearly like, and I'll share with you guys again my summary page that I've created just after the session as well. And basically it is to follow the steps. So I'll nearly show you in all the examples as well today how I would have done it. So I'll first look at the null hypothesis. And alternative, I'll decide if it is a one-tail or two-tail. Then we go into the level of significance, the alpha, that all they give it to you, or they tell you about a 95% or 90 or 99% confidence. Then we need to, in some instances, we need to calculate the relevant t statistic, and then we must compare it to decide if we're going to reject, or if we're not going to reject or fail to reject. So again, I'll show you some of the words that they can also use when you look at these examples. Then I think the other two things that is just important is you'll see the t-stat when we have, again, population standard deviation that is known. So basically the work that we've done in study unit 7 and 8 is now coming back into this one again. So when we know that your population standard deviation is known, we work with a Z. So again, we go to a Z table. They need to give us enough information that we can get to that Z. If the population standard deviation is unknown, or if I talk about the sample standard deviation, we'll go to the T again. And then we will need to work out the T value with this information. So when we compare the t-stat of a Z, we go to the Z table to compare it. When we compare the t-stat when it is unknown, we basically will compare it with a t-table. So again, just the difference: when it is known, we use the Z, compare it to the Z table. When it is unknown, basically look at the sample. We work out a t-stat with the t. So everything in here will be exactly as they give you in the question set. So nothing really is different from what is up above. But when you compare it, you will compare it to your t-table. And again, I shared the t-tables that they shared last year for your exam. So you will use that set of tables, just that it's not different to a one you have in the book and different to some of the other options that is available, just to make it simpler and to use that. Okay, so the first thing before we go into some of the examples, I just wanted nearly to show you the one and two tails. So when something, your hypothesis, your null hypothesis equal to, and your alternative hypothesis is the not equal to, that is basically when you have the two tail. For any other option, you will have the one tail. So where your, and let's make it your, if your null hypothesis, we don't really worry about what the null hypothesis is for the one tail. What we are looking for is what is the alternative. So if your alternative is bigger or equal to, smaller or equal to, you basically work with a one tail. Okay, so depending on your null hypothesis and your alternative, that is where the difference will be between a one tail and a two tail. So if it is then a two tail, so let's just, and we work with say 95%, then your 95% will lie between the 2 points. Okay. If we work with a one tail and we have again 95%, how would that look like? Anybody that want to nearly take a guess how that would be structured? Okay, so if we had the 5% alpha, alpha looks something like that. We would divide the 5% divided by 2 to get into that one and that one for two tail. When we look at the one tail, that basically is your alpha, which is equal to 5%. Okay, so then that value and that value is not the same, because that would have been for the two tail, that would have been equal to 97.5. And this one is only equal to 95. And that's why you can nearly again use the, let me quickly see what the page number is, that's in your study guide, where they have that table, and when they say for one tail and two tail, basically the 90%, 95% and 99, that is nearly, those are the only three that you will see in an exam. So again, we'll copy it into this slide presentation afterwards when I share it again, but also I'll share it with you on that one page that I've done, just that you nearly have that again when you do the assignment, but also when you do your exam, that you nearly have that all together, so that you don't need to nearly work it out, that you have it, just to save a lot of time. Okay, so let's go into, is there any questions before we go into some of the examples? Okay, so let's go into some of the examples, and nearly what I first want to do is run through all of them and first look at the hypothesis. So, okay, that should have been H0, you can't have two alternatives. Okay, so H0, the null hypothesis equal, alternative is not equal, so we work with a two-tail. Let's look at the next one. Null hypothesis equal, alternative hypothesis bigger than one tail. Equal, not equal, two tails. So basically, I just first want to, okay, that one we'll do as a separate. Null hypothesis equal, bigger than one tail. Null hypothesis, okay, here we need to see whatever they give us. So first we need to read through that, so we can't say at the moment. And here we also need to do something else. So nearly first want to identify what is two tail, what is one tail, and then we can look into the rest. So with this one, they give us the population standard deviation. So with that, we know it's going to be a Z that we're going to work with. N, there's your alpha. Okay. So with the first question, which one of the following statements is incorrect? So again, just be wary of that incorrect. I've seen in assignment 1 and 2, they use a lot the incorrect statement. That should be a two-tailed and not a toe-tailed. So two-tailed is used. Yes, two-tailed is used. Okay, so that's still not incorrect. Standard error is 20. We can work that out now, but the t-stat is minus 0,1. We'll work that out. The critical value is 2,58. Okay, so let me get to my table that we can just check that, if that is correct or not. So if I look at my table, we can, let me quickly see, I haven't written down the table yet, but if you look at your table, we'll probably get that answer, and then we need to make a decision. Okay, so let's start with standard error. Standard error we've seen again in study unit 7. Your standard error is your standard deviation divided by the square root of n. So standard deviation is 200. Your n here is 100. So square root of 100 is 10. So standard error is 20. Standard error is 20, so that is correct. So again, nearly if you look at the hypothesis testing, you need to understand study unit 7 and 8 to move into study unit 9 for hypothesis testing, to get some of those concepts as well, because this was out of study unit 7. Okay, so let's look at the t-stat. So the t-stat we will need to calculate. So we've seen that we're working with a z. So z is equal to x minus that divided by the standard error. So we can already say that is divided by 20. So we can use that answer already. So the x is 980. That is a 1000. So that is minus 20 over 20. Okay. So that is equal to minus 1. Okay, so the t-stat is equal to minus 0, 1. So that is the one that is incorrect. Okay, but let's just look at the critical value. So when we look at that critical value of a two-tailed 99% is 2,58. So on that table, we have the 99% as 2,58 for two-tail. And just then, how do we get to the 99? So how do we know that we can use the 99%? Because alpha is equal to 0,01. So minus the 1 minus the alpha gives us the level that we're going to test again. So 1 minus 0,01, and that is 0,99. Okay, and then if to put that in a percentage, it's times 100. So that is how we get to the 99% level that we test against. So that is also correct. So how do we decide if we accept or reject? So let me use another color, and let's just then draw something in here. So this part will be that. So how do we accept or reject? Remember, that is nearly where it is 0. So the t-stat that we calculated is actually minus 1. The critical value is 2,58. So when your t-stat that you calculate is within that region, and even if it was minus, we basically say that we reject the null hypothesis. If that is bigger, we say we accept the null hypothesis. So it's all dependent on these two numbers if we reject or accept the null hypothesis. We can also look at, okay, we haven't done it to work out a p-value. We will only get to that later on, to work out the p of a minus 1. So we will only get to that later on to see what is that actual size. So if that value again is bigger than the 0,01, we will reject the null hypothesis. So we can go to z minus 1 on the negative table, and we can look at what that value is. Yeah, it will probably be something like 0,15 or 16 or something like that. Okay, so basically what we then see is that we will reject the null hypothesis. Okay, so in this question, we nearly, if you look at the steps that we have taken, we've done that. We've looked at If it is one tail or two tail, we've looked at the alpha to see what we're gonna use. We worked out the t-stat. Then basically we looked at the critical value in comparison to the t-stat to decide if we're going to reject, if we're going to accept whatever we're going to do with a null hypothesis. Okay, so I think that, and you'll see we'll continue that process now with each of these questions. So we looked at one tail or two tail. We looked at to calculate the t-stat. We looked at the critical value. Now something new has been brought in is the p-value. So again, we'll add that extra dimension to this question. Okay, so bigger means that we only look at a one tail. Unfortunately, again, the incorrect one. So one tail is appropriate. So let's look at what they also give us. They tell us what your mean, your n, x. They don't give us standard deviation. Am I missing that somewhere? They don't. No, they don't give us standard deviation. So how can we do this without standard deviation? Okay, so they talk about critical value. Okay, so let's just see if we need. So my first question with this one is basically, but where is the standard deviation or standard deviation? The critical value at 2.5% level is 1,96. So if we look at one tail and we look at that, so that we know is 95, but if we look at one tail, I just want to make this that I can explain it. So that is where the difference now comes in as well. So the critical value at 2.5. So that would tell me that that is 2.5. That is 2.5. So it would have been fine if it was a two-tail. Then my critical value would have been 1,96. But now I deal with a one tail. So I don't know what that is because I don't know again if we're working with a Z or a T. Okay, so if it was a Z, that would have been wrong because then at the 2.5 level, it must be something different. So this is not a great question because unless I've missed with a standard deviation, so I'll need to go back to this in the study guide and see actually if they have given the standard deviation. But if not, we basically can't do this. And it doesn't matter if I does this or I do this, because we need to or look at the Z or the T. So again, it can be different answers for those two different tables. Okay, so I will definitely relook this because you can't calculate this without standard deviation. Okay. Does anybody have, let me quickly just go to the, while I have this, let me just quickly go to the study guide and see what is wrong with this one and if this was just like that in the study guide. Because I'm worried that this is just like this in the study guide and then nobody can actually get to her answer. So while I'm quickly looking at this one, is there any questions at the moment and the process that we're following? Okay, no, so there is definitely so in the question, so yeah, so this is one area where not all the information was given. Okay, so we can't do question 2. So again, if you look at the options, we need to have more than that. So let's go to question 3, where I think we have enough information. So we've got the sample, finally got the standard deviation. It's a population standard deviation, so we can work with Z. We've got the sample mean. We've got a 0.05% level of significance. We've got equal, not equal, so we know it's also a two-tail. So let's look at the options. Again, incorrect. A two-tail test is appropriate. Yes, it is, because we've got the not equal. So when we have a not equal, it is two-tail. The critical value is 1,96. So if that is alpha, we know that 1 minus alpha is also your level. So your level is 95%. If you go to your table in the study guide, you will once again see at 95% the level, your Z value for two-tail is 1,96, so the critical value is correct. Okay, we need to work out the t-stat, so let's work it out. We've got we've got all the information. So X was 458. Your mean, you're testing against 450. And when you divide by your standard error, which is your standard deviation, divided by the square root of n. Okay, so that one I need my calculator for. I can't do that. So 458 minus 450, that at least is 8. So square root of 35 is 5.916. So if we say 1 divided by 5, or the 20.5 divided by the square root of 35. Okay, wait, let me just do that again. 20.5 divided by square root of 35 is 3,465. So 8 divided by that is 2,31. Okay, so, and I round it off to the number of decimals that are there, so 2,31. Okay, so the t-stat is also correct. So once again, the t-stat that we've done in study unit 7, we are using again in study unit 9. Okay, so one thing now new that we're bringing in is the p-value. So the p-value is connected to the t-stat. So when we look at this, we will now see that your z value is sitting here at 1,96. Your t-stat is sitting here at 2,31. Okay, so basically what we want to work out with this p-value is that p-value, whatever that value is this small area. Okay, so we need to find out if that area is 0,0104. Okay, so for this again, now we will go back to your Z table. So to work that out, we will go to the Z table. We will go to the Z table. I would use the negative Z table where it is minus 2,31 so that I can just get the smaller area. So let me quickly show again how I would have done that, and hopefully that answer is then or equal to that or not. So it will again be quite interesting to see. So let me just, okay, so that was Poisson, so it will be the next study unit. Okay, so we were looking for Z that are equal to 2.31. Z equal to 2.31 will give you that. So let's just go to the negative so that I can get the small area. So I want to get to that small area basically. So negative 2.31, 2.3, 2.31, 0.104. Okay, so zero, 1, 0, 4. Okay, so now the big question is that correct or is it wrong? So what would you have said? Correct or wrong? And if you don't know, you can guess as well. Just want to get nearly a sense what you guys would have done. Okay, so let's quickly look at this again. So we're dealing with a two-tail. So how big is that area? Also 0.0104. Okay, so when we working out the p-value, we need, in a two-tail, we will, whatever this value is, we will need to multiply it by 2, because on this side there is also a piece. And that nearly brings me back to this one where, and let's quickly go to, so when you have a two-tail, you have both of that side. So when they give us that value that we're working out, we need to remember it is only for that piece. So when we deal with a two-tail, we will need to multiply it by 2 to get the other part as well. Okay, so this one would be the incorrect one. So then let's look at H is rejected at the 5% level. So I think what is again important is to look at the wording. This is your T-stat. That is your critical value. If your critical value is again smaller than your T-stat, we reject. If it is bigger, we would have accepted it. Okay, so it's again always looking at where's your T-stat compared to your critical value. Okay, so this is really a lot of information nearly to take in, because it's not as simple as just working out one value. So nearly your first, let's just do that. Your first step is, let's look at the one or two tail. So one of your options will always be nearly, is it a one or two tail? Then I'm just making these two. So one of it will be that you need to work out your test statistic. One will be with your critical value that you need to look at that. The critical value, what is important is, depending on what the one or two tail, your alpha can, you need to look at that. The fourth thing that they can bring in is your p-value. And again, depending on one or two tail, you read it off a table as is, or you need to multiply by 2. And then normally your fifth option is that they talk about reject or accept your null hypothesis. So sometimes I can even go further to say, look at reject or accept your alternative hypothesis, but mostly it is looking at the null hypothesis. So that is nearly the 5 things that in each of the longer questions you will nearly need to work out and to get. Okay, the critical value, you look at your alpha. So there you can use the table that is in your study guide. The t-stat you will need to calculate if it is the t-table or the z-table. Okay, so let's quickly look at the next one. And this is also something that they like to ask in exams. It's nearly to give you options of a null hypothesis and alternative hypothesis. Okay, so the first thing that I nearly want to show you is when we talk about the mean and what we work out in null hypothesis, it's always this. So it's always that sign. So when they have the x, it is not correct. Okay, so now that we've at least eliminated one, so let's read the rest. A professor of statistics refuses the claim that the average student spends 3 hours. So he says that he does not believe that it is 3 hours. So your null hypothesis is 3. They don't tell us. So they tell us that he refuses the claim. Okay, so he does not believe that it is 3 hours. They don't tell you that it is more than 3 hours or less than 3 hours. So you don't know if it's more or less. So if it's, you don't know, so you just say it is not 3 hours, so it is not equal to 3. Okay. If I said it is more than 3 hours, that would have been your null hypothesis. If I said it is less than 3 hours, that would have been your null hypothesis. So if you look at, that is your, sorry, your alternative hypothesis for those two. So that is your null hypothesis. So it was that one and that one, that's options. Your alternative hypothesis is not equal to, so there's only one. So option 2 is the correct one. So again, this one nearly, depending on the words, that is how you eliminate some of the options as well. Okay, so let's look at the next one. Calculate the p-value. So to calculate the p-value, we will need to work out what is the z value. We will need to look at this diagram, and wherever the z is, we will need to work out the p-value. Okay, I now assumed it is z, but it can also be t. So let's just look at what is the rest of the information. Calculate the p-value of the test of a following hypothesis given sample proportion. Remember back again in study unit 6, sample proportion is always z. Okay, so it is not t, so we're working with a z. The proportion is 0.63, n is equal to 100, and the calculated t-stat is 0.05. So they actually give us that. That's quite interesting. So they tell us, okay, so that is your 0 of your z. They tell us that is 0.05. Then they tell us the null hypothesis and the alternative. So we're working with one tail. So because it's one tail, that answer is my answer that I'm looking for. Okay, so that answer is the one that I'm looking for. Okay, so if you then look at these options, we know from the previous study units that that side is 0.5. Okay, as probability. So if we have it here as z is equal to 0.05, this area that we are looking for will be smaller than 0.5. So even without working out anything, if any of these numbers are bigger than 0.5, we know it's wrong. So that is wrong, that is wrong, that is wrong, and that is wrong. So without even looking at the Z table, that is your correct answer. But let's look at the Z table. So again, I want to get that area. So instead of working out that total area with a positive table, then say 1 minus that area, I'll go straight to your negative table. Your negative table, then I will look at minus 0.05. So it's 0.4801. Let's just see, it's 0, 1, 2, 3, 4, 5. So 0.4801. 0.4801. Okay, so again, using the table like we did in study unit 7, we basically can work out what is the probability. So the p-value that you're working out is basically working out the probability of that t-stat that you have calculated. So other nice way to look at it is that your critical value is linked to the alpha, and your t-stat that, and I just call it t-test, is what you then link to your p-value. Okay. So let's look at the next one of a lot of information again. So a popular weekly magazine asserts that fewer than 40% of households in South Africa has changed their lifestyle because of escalating gas prices. Okay, so fewer than equal to, so that is correct. So fewer than is your alternative hypothesis, and that is smaller. So that is correct. We again looking for the incorrect one. So let's look at what else do they tell us. A recent survey, 100 households. So we're going to work with a p proportions again. So if we're working with proportions, I know that we're going to work with Z. So we need to work out that Z. So again, if we look at proportions, we need to work out, again, from study unit 7, we would have had that the Z of a proportion is okay, so it will be this formula. So let's quickly get that just written down. Okay, so we know that what that value is 0.4. So the p-value in this one, the proportion is 67 divided by 100. So 67 divided by 100 is that proportion value, and that is equal to 0.67. So 0.67 minus 0.4 divided by that calculation. So let's just write that down. So that would be 0.4. 1 minus 0.4 will be 0.6. And that divided by n, which is 100. Okay, so let's look at what is that. So basically, nearly what we've done in study unit 7, we are doing here again. So 0.67 minus 0.4 is 0.27 divided by 0.4 times 0.6 divided by 100, which is 0.0024. We need to take the square root of that. So that divided by 0.049. We need to get to 4 decimals. So I just changed my calculator to 4 decimals. So 0.27 divided by that gives us 5.512. So that one is correct. So once again, just look at the decimals that you are working with, so that we can get to the same answer. Also, when you calculate this and you get an answer of 5.5104 or even very close, they're not going to give you an option of somewhere else, one of the things that is just 1 decimal to the 4th decimal. Maybe if it was 5.5103, they're not going to give you that option as well. So I just think also when we look at this, there's certain things that they're not, they will make sure that it is very close, or even if that is then rounded off to the 2nd or 3rd decimal. Okay, so then the critical value, they don't tell us in here what it is, but again, if we look at the alpha of 0 or 10%, 1 minus that alpha is at a level of 90%. Go to the table in your study guide, alpha or level of 90%, 1 tail, because we know it is 1 tail, that is equal to 1.28. So nothing that you need to work out, don't need to go to one of the Z tables in the back of a book or anything like that. You can just look at that table in study unit 8. It was given with a confidence intervals. It was again repeated in study unit 9. You can just use that as is. Nothing that you need to work out. So that is also correct. What happens with this p-value? And you would see that when we look at the Z table, you would see that it ends at -3 or +3. So, and the other thing that you would notice is that 0.001, then it becomes 0.000, and it becomes smaller, and well, from that side, sorry, because that is going to be 3.09. So you can see all the way 0.06 here to that place where it becomes smaller and smaller and smaller. So if we had a -5, that would be just much smaller. So it will go to 0.0000. So unfortunately, so what they should actually have done is rather to say here your p-value is smaller than 0.0010, so that you know that it is even smaller. So this one is correct, but it would have been nicer if I just told you when you look at your Z table that it is actually smaller than that, even because as you go higher up to the negative -5 or +5, that becomes a very small number. So it would have been nice if I've given you a sense of smaller than what. Okay, so that one is also correct. So then we look at this, we look at where the critical value will be, we look at where the T stat will be. So on that side, we will, again, like we did with, was it that one that I showed? No, where was it? So again, if a T-stat is bigger than the Z, we reject the null hypothesis. T-stat bigger than the critical value, we reject the null hypothesis. So what they tell us here is H0 is not rejected, so that is the mistake. It should be rejected. So question 5 or option 5 is the wrong one. Okay, so again, nearly when you work it out, your T-stat that you work out, if that is bigger than your critical value, you reject the null hypothesis. Okay, so nearly in all of these, we rejected the null hypothesis because the T-stat that we calculated was bigger than your critical value. Okay, so let's look at the last one. Maybe it's something different. So here you can see reject null hypothesis, do not reject the alternative hypothesis, need more information. That is normally not an option. Just from experience in this, they normally give you enough. Why they include that is to nearly confuse you and give you just enough information, but you think you need more. Okay, so let's look at what they are telling us. In testing the hypothesis, null hypothesis, and alternative hypothesis at the 5% significance level. Okay, so let's look at that. 5% significance level. So 1 minus alpha is equal to 95%. At that 95%, we have a one tail. So if I go to my table, 95% one tail, I get the Z value of 1,645. Okay, so Z value of 1,645, that is my critical value. If my T value is somewhere here, if my the T-test that I'm working out, if that is sitting here, what did we say we'll do? We will basically reject the null hypothesis. So if my T-stat is sitting here, we reject the null hypothesis. If my t is sitting somewhere in this area, we accept the null hypothesis, or we do not reject. So that is also wording that they can use. So we basically not reject the null hypothesis. So let's look. They tell us the p-value is equal to 0,0764. Okay, so they tell us that whatever this area is, it is equal to 0,0764. Okay, so before I do that, when I look at the 95, I look at that value, how big is that portion there? Okay, so that portion would have been 0,05. So this portion where it's 1.645, that area would have been 0,05. Okay, so now I'm telling you that that portion is actually bigger, so it is 0,0748. So if it is 0,0748, let's get another color here. That will be my t-test that I calculated. So that will be the one that I have calculated. So if that is lying to the left of the critical value, we accept null hypothesis, or we do not reject the null hypothesis. Okay, do not reject the null hypothesis. Okay, so option 2 is the correct answer. Okay, so we had enough information nearly to do that. What we also could have done is we could have checked on this table. I just want to get that number again, 0,0764. 0,0764, so 0,0764. Okay, which was then 1,43. Okay, so we could have gone to the Z table. That value would have been 1,43, which would also show us that that value is lying to the left of 1,645 because it's smaller than the 1,645. So we could have used this to get that from the Z table, and then also to compare that to the 1,645 from the confidence or the significance level. Okay, so that is, for me, study unit 9 is nearly the most difficult one, because it looks at your study unit 7, that you understand what happened in study unit 7, but then it brings the extra difficulty in of really looking at the Z, comparing it to the t-stat, and then you need to make a choice with the information that you have available. So I think I'll schedule another session next week that we can just recap study unit 8 and 9 for your assignment that is due on the 2nd of August. Okay, questions on your side that you quickly want to ask, or is it at least making a bit more sense? Okay, you guys happy or just taking in a lot?
I think we're just taking in a lot.
Okay.
I just have to go through the recording again.
Yeah, this for me is really a difficult study unit. So, and you can see it's not that we covered a lot of examples even, and it took us an hour. So for me, this is really one of the more difficult study units because it is a lot. It is really a lot that one needs to take in. Okay, so I'll post this still this evening. I'll share the video and the link, and but I'll definitely schedule some time next week also that we cover study unit 8 and 9 again, just a bit more information for you and guidance. Okay. Have a good evening, everyone, and see you guys next week again.
Thank you, Jane.
Cool.